Integers is a math concept that's often skipped in elementary schools, but truthfully, the foundation for the idea of positive and negative numbers could be taught at a very, very young age. The foundation for the ideas behind integers and this abstract representation of something that we do or do not have, or that we've gained or lost, can be very important to young students, and it should be built upon as they get older in elementary schools. Students, and teachers alike for that matter, often get confused about all these different terms that represent numbers. We have integers and real numbers and whole numbers and fractions and all these different things. And while we probably would not introduce the word integers right at the beginning, when we are ready for that, we want to make sure that students understand what an integer is. We're talking about positive numbers, we're talking about negative numbers, and we're talking about zero. Number lines are very good ways to show this once we get to that point. Integers are ways to express things that we have, but also things that we don't have, what's lost, gains, losses, changes. They're ways to show something that's really quite abstract, but also real. The foundation for this is important because if students don't get that, then as they move forward, they become confused. The good news is that there are so many ways to help students understand the concept behind integers involving things that they already know. We can have something, we can be missing something. We can get something from somebody, or we can owe something to somebody. We can be above a certain identified point or below it, after, before. Positives, negatives, all these different terms can be connected to things that students already have experience with, and that's very, very important. Another really important conceptual idea that needs to be taught at some point near the beginning when we work with integers is this idea that if we have the same amount of something that's positive and negative, and we put those together, we're going to end up with zero. We're going to end up with nothing. This is a foundational concept for algebra, and it's something that students need to be taught because it can be applied to so many different parts of math. So if I have 3 books in my hand, that's positive. I have 3 books. If I give them away to somebody else, I'm missing my 3 books. I'm negative 3 books. There are 3 books that I don't have. If I have 3 books, but then I take the 3 books away, I have 0. So a positive 3 and a negative 3 together end up with 0. That's an important point to help students understand, and it would take many different practices with different kinds of objects to help them see that the positive and the negative of the same number, of the same amount, will always result in 0. Helping students understand positive, negative, reversals, opposites, all of this can be blended together when we teach integers, and again, it can be tied to things students already know. So if we have students who get paid for something, they get an allowance at home, they get paid for mowing the lawn, they know that when they get money, they're in the positive, they have the money. When they spend the money, that positive amount goes down. And if they spend more than what they have somehow, then they're going to owe someone money, which means they're in the negative. So again, real life things that are parts of students' lives, like money, are hugely important. After we get them to understand this abstract idea of I either have something or I don't have something, I am in the positive or I am in the negative, then we can start introducing the academic language, the word integer, positive, negative, whole number, 0, making sure that they understand what those terms all mean and how they fit together with the discussion that we're having. We can also use language, which is kind of fun. Students enjoy this. If I say to my friend, I'm coming to your party on Friday, then my friend will see me there. If I say to my friend, I'm not coming to your party on Friday, then my friend won't see me there. But if I say to my friend, I'm not coming to your party, then probably they are going to see me there if I'm not. That's where that double negative, that double reversal comes in that takes us back to the place where we started. That's where the idea of 2 negatives makes a positive can come from in a way that students can understand and something that they can relate to. So in a strange way, saying I am not coming to the party is the same as saying I am coming to the party. It's like that first negative, I'm not coming, is reversed by the second negative, I'm not coming, and that results in a positive. I am coming to the party. Once students understand those basic ideas, what does it mean to be in the positive? What does it mean to be in the negative? with terms and ideas that they're familiar with, then we can start adding the digits. And a really nice way to do this is to use number lines. Number lines are hugely effective for teaching integers. We can have students walk on a number line. They can start at 0. They can go to the right and take positive steps. They can go to the left and take negative steps. We can start with just that idea of 0 is the neutral point, positive goes this way, negative goes this way. And once we get to operations, we can use those things and have students actually walk them. So for example, if we had a simple problem like this, we can say to students, okay, start on 0. You're going to move to positive 4 because that's the starting point. We're starting at positive 4, that's what we have. And now what we're going to do is we're going to add a negative 3. Now typically when we add, we would get bigger. We would turn to the right and go farther that way on the number line. But because we're adding a negative, we're going another direction. I have seen teachers have students walk backwards when they have a negative so that students understand it's a reversal. And I have seen teachers have students actually change and turn to go the other way, making a 180-degree turn, a reversal, when they do negative. I've done both in my teaching, and I will say that I have had more luck with the actual turn, because when we get to things that are a little more complex, it seems like that turn helps them understand that change in direction. So if we have this problem, then our students start on positive 4. They add, which means they face the right of the number line, the bigger side, but then they see a negative 3, which means they're going to turn to the left and take 3 steps. So if they start on a positive 4 and they take 3 steps, they're going to end up on positive 1 because they've gone backwards 3 steps. So the number line really helps students see this, and the movement is good for students. I actually would do this with students quite a lot. Even when students start to understand, I would warm up my math class if we're studying integers with these kinds of things to make sure they have it in their head. Once students understand that, then you can actually move to a real number line. And I used to put number lines on my students' desks so that they could actually use them. So if I start at 0, and then I say, okay, I am going to move negative 3 steps, 1, 2, 3. I'm going to end up there. Now, if this is my problem, then what does this problem mean? This means I'm going to move negative 3 steps 2 times. So I'm going to go 1, 2, 3, that's once, 1, 2, 3, that's twice, and my answer is negative 6. So we want students to actually see this. We want them to be able to do these kinds of problems on the number line and transition from the actual walking and the moving to the number line. So if we had a problem like negative 3 plus 5, then our students would be on 0 and they would say, okay, my starting point is negative 3, that's right here, and I'm going to add, that means I'm going to the bigger side, I'm going to the right, 5. So 1, 2, 3, 4, 5. I'm going to land here, and my answer is positive 2. We can also use chips, 2 different colored chips, to teach integers. One color for positive, one color for negative. Doesn't really matter the color as long as the students are clear about which color is which. In this particular case, I'm using black for positive and red for negative. So as I look at these problems, let's just see how we want students to think using chips. If I have 3 plus 4, I have 3 positive and 4 positive. That means I have 3 black chips, and I'm going to add 4 more black chips. So I'm going to end up with 7 black chips. That means that my 7 is positive. If I have 3 black chips and I'm adding 4 red chips because they're negative, this is where we get into that combining, that positive and negative. So if I combine these 2, they cancel each other out. So do these 2, so do these 2, and I'm left with 1 negative chip. Because a positive and a negative together makes a 0, and they cancel each other out. Now you can see why it's so important to build that foundation ahead of time, because that's a little complicated. We have to make sure that students really are sold on that idea of a positive and negative of the same amount will result in 0. Otherwise, this will just be a procedure and they won't really understand it. Basically, what we want students to understand here is that I have more negatives than I do positives. So my answer is going to end up on the negative side. And if they get confused with that, we can always go back to the number line. In the next problem, I have -3, so that's 3 red chips. And I'm going to add 4, that's a +4, so that's 4 black chips. So again, if I combine, negative and positive is 0, negative and positive is 0, negative and positive is 0, this time my answer is +1 because I'm left with 1 black chip. In the next problem, I have -3, and I'm going to add -4. Well, in this case, I just have 7 red chips, so my answer is -7. In the next problem, I have +4, and I'm going to take away +3. There's no extra negative sign there. So I'm going to take away 3 of these positive chips. These are going to be gone, which leaves me with +1. The next two problems really show how this combining of a positive and a negative to get 0 can be really helpful. In the next problem, I have +4, 1, 2, 3, 4, and I'm supposed to take away -3. Well, negatives are red. I don't have any red to take away. So how am I going to take away red chips when I don't have any? Well, the answer is I'm just going to throw some in there. I'm going to add 3 negative chips. So I have some red ones. Can I do that? Well, not unless I also add 3 black chips to even out those red chips. Because as I look at what I just added right here, if I add the 3 red and I add the 3 black, they cancel each other out. That's the same as adding nothing. That's the same as adding 0. So once students understand that I can do that, then I can do this problem. So now I started with +4 and I want to take away -3. So if I take away the -3, that means taking away those red ones. And what am I left with? I'm left with +7. On a number line, we can do this as well by talking about reverse directions. This is confusing to students because they're saying, yeah, but you're taking something away. How can you end up with more when you're taking something away? So that idea of taking away a negative, making a bigger amount than what we started with, is confusing. And we'll have to explain that very carefully to students using other ideas. In this problem, I have -4, and I want to take away a +3. I don't see any black dots there. I don't have any positives that I can take away. So I'm just going to add in those 3 positives. But if I do that, I also have to add in 3 negatives because 3 positives and 3 negatives together equal each other out. They cancel each other out. They're like adding 0. So I've just added 0 to this problem by adding 3 negative and 3 positive chips. Now I can take away the 3 positive chips. If I take away these 3, then what am I left with? I'm left with -7 because the chips that are remaining are red. So that's a negative answer. In my last problem, I have -4, and I want to take away -3. Well, I have -4. -4 means red. I want to take away -3, so I want to take away 3 red chips. I can do that. So I'm left with 1 red chip, and my answer is -1. This is, in a way, a very concrete way to teach very abstract ideas. The ideas of negative, the ideas of something that we have that's in the whole, something that we don't have. But by using chips and something real, it can help students who struggle with that idea. It's representative. My personal opinion is there is really no shortcut for teaching procedures when it comes to integers. I think students have to think about the why in every single operation. I think they have to picture it. Now, there are some rules that we can apply. When we get to multiplication and division, we can say 2 negatives will make a positive, or if there's a positive and a negative, the answer is going to be negative, or 2 negatives make a positive. But the truth is those rules only apply in certain situations, and for many students it's confusing. So if they don't understand the why, they're going to be lost, and they're probably going to make a lot of mistakes, even just with what sign to add. So for example, looking at these problems here, if we use a number line and picture a number line, I think it will help our students. 3 times 4, that means we have 4, and we're going to take that 4 3 times. So on a number line, we're going to start with 4, get to 4, and we're going to hop by 4s 3 times. 1, 2, 3. So if we had numbers on this number line, and we hop by 4s, we would end up with 12. So that's the idea. That's the kind of thinking we want our students to use. In the next problem, we have -4, and we're going to hop by -4 3 times. So that means on our number line, if we start with 0 and we hop by -4s, we're going to go this direction 3 times, and we're going to end up at -12. So we can use that kind of thinking with all of these problems. Here we have 4, and we're going to hop -3 times. -3 times means we're going that way, so we're going to end up with -12. Here we have -4, and we're going to hop -3 times. Now that means we have to change our direction. We're hopping by -4s, but we're doing it -3 times. Negative in that case means opposite. So we're actually going to end up hopping this way 3 times. So our answer is going to be +12. If we take that idea into division, let's picture a number line where we have 0 here, and we have a +12 here, and a -12 here. So in this problem, what we want our students to be thinking is, I have +12, and I want to know how many 4s are in that 12. How many times can I hop by 4 to get to 12? Well, if my numbers were all here on the number line, I could go 4, 8, 12. I would hop 3 times. In this problem, I again start with 12, +12, and I want to know how many -4s are there in that 12. Well, the truth is, if I start here and I start hopping by -4s, I'm going to go that way, and I'm never going to get to my 12. So what do I have to do? The first thing I have to do is I have to change my direction. That means that right off the bat, I know my answer is going to be negative. So I change my direction, and I hop by 4s, and again, the answer is going to be 3. But I had to change my direction, which means it's -3. If I start at this end of the number line, where I have my -12, in this problem I start with -12, and I want to know how many +4s are there in -12. Well, if I hop by +4s, I'm going to be going this way, and that's never going to get me to a -12. So what do I have to do? I have to change my direction. And if I change my direction and go this way instead, and then hop by 4s, I'm going to be able to do it 3 times. But because I changed my direction, my answer is going to be -3. Those negative signs represent that change in direction. And in the last problem, I start with -12, and I want to know how many -4s are in that -12. So if I start with 0 and I hop by -4s, how many times will I hop before I get to -12? 3 times. And I did not have to change direction. So I don't have to add a negative. My answer is +3. I hopped 3 times to get to -12, hopping by -4s. So this whole idea of the negatives and the positives and the changing the direction and common sense, I think needs to be taught all the way through integers, even when we get to the point where we're using procedures. Now, some students will understand this pretty clearly. They'll be able to picture it and do it more mentally, and that's great. Let's encourage that. But if they can't, let's let them use that number line, use those conceptual ideas, because this is a very abstract idea. Getting back to one last thing that's important about integers, and that is this idea of absolute value. Later, when students get into higher levels of math, they will talk about absolute value. Absolute value, really, on the simplest level, is what we've already talked about. It's like saying, I have 3 chips, and they happen to be negative. So if I have 3 negative chips, how many do I really have? I have 3. They happen to be negative, but I still have 3. That's their value. So the absolute value of a -3 is 3, because that's how many there are. Now with positive numbers, this is easy because we see them. It's there. It's something real. If I have 7 apples, how many do I have? I have 7. That's the absolute value. But in negative numbers, the negative only means the direction we're going. It only means that we don't have something instead of the fact that we have something. But the value of it is not different. The value is still the same. So we represent the absolute value with these lines, and we drop the negative sign. Because even though our chips are 3, or even though I owe somebody $5, the value of that is the same. 3 chips, $5. These skills help students later on if we teach the foundations very well and conceptually in the elementary years. I always encourage teachers to integrate math with other subjects whenever possible, because math is everywhere. It's in English, it's in reading, it's in social studies, it's in science, it's in the world. Integers is no exception. If you look at the list on this slide, you will see so many places where we can be talking about positive numbers, negative numbers, 0, and these are things that students can identify with. These are things that are in students' lives. Let's never forget to make the math that we're teaching real, to get beyond the problems to how this math is used in the world.